which means you are given a linked list. Again, in a linked list, you are always given the head of the linked list, which is 1. So you will be given the head of the linked list. That's it. And then the links, which means next, 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 next. You will be given like these. You are said that you have to reverse it, which means once, okay, it was the head. Now the head will be the 5. Its next will be 4. Its next, 4's next will be 3. 3's next will be 2. 2's next will be 1. And 1's next will be 1. Null. So you can see 1's next is null. 2's next is 1. 3's next is 2. 4's next is 3. And 5's next is 4. That's what we are saying, that we have to reverse the linked list. Now, first, the most easy and the most iterative, the most easy way, we will see that, okay, Aryan, we are at this specific head. So you said that this head, I want to make it as null, and the next one, whatsoever it is, the next element which I have, let's say the next is 2. So 2's now next should become a 1, and this pointer should go away. Rather than this pointer, I said that it will be pointing back, and for the next element it should be pointing to its previous element. That's more obvious that, okay, I need a previous, I need a next. So what I can do is, okay, I can take a previous pointer, I can take a current pointer, and I can simply say, okay, previous pointer right now is pointing to null because I don't have anything. So I can simply say that, okay, current's next will point to previous. And first, one basic thing is, I initialize my previous to null and current to head, because I know that, okay, although I can say heads next is null in the very beginning, I can add an if condition, but I can say, okay, I know I will be shifting this previous current like this. So why not in the very beginning itself, currents next I can point to previous. But oh, you missed something. That's what you wanted. Currents next is now null. Now you will just shift. So previous was null, current was 1. Now your previous will become 1, current will become 2. Previous will become 1, current will become 2. But bro, one question. How did you shift this? Okay, you said to shift this, so I will just say that previous will become current and current will become current's next. But bro, current's next is now null. Current's next is now null. So you missed current's next because of breaking this link. So what I realized was, okay, I had my previous, I had my current. I also need one more pointer, which is current's next, so that I know I have to shift. Previous can shift to current, but current also should be knowing whom he has to shift to, because the links will get broken or basically not arranged. So I will just maintain one thing, okay bro, in the very beginning, previous will be very left pointer, current will be the next pointer, and current's next will be the next pointer. So that this current next will help me, okay, current in the next move should move to current next, but previous should move to current, and this current should move to current next. That's how I can simply do it. Now, very simple, that how to achieve these pointers. Simple. Current next is nothing but current's next. So to achieve current next as a pointer, I will say current next is nothing but current's next. Now, when I have achieved these 3 pointers, okay, previous I have achieved, current I have achieved, current next I have achieved. Now, to move the pointer, I'll simply say that previous should move to current. So previous, so firstly, my current's next, again, my current's next firstly should point to previous. When this pointing and stuff is done, which means my current next is pointing to previous, this is not pointing anymore, then I can simply move all of them. Okay, previous should move to current. Okay, previous should move to current, and current should move to current next. Current should move to current next, and that's it. That's it. And by this, I can simply keep on moving. Let's have a quick dry run of how things will go about. So you saw that we had our previous in the starting pointing at null, then we had the current, and then we have the current next. So now my 1 is pointing to null, and I have such a situation. Now we saw everything will have moved one step ahead. So now my previous is at 1. Again, remember that 1 is pointing to null. That's done. Null PTR. Okay. Null PTR or null pointer or null. Now I have my previous here, current here, and current next here. I have just plotted them very easily. Current next will be simply always a current's next, and previous and current, they have moved one step. Now again the same operation. Current next should point to current next should point to previous, which means this pointer will go away, and I can easily get away with this pointer because I have already marked my currents next in some new pointer. So first operation is to marking current next. After that, mark currents next to previous. right? Okay. Now, I'm again good. So again, I'm reaching towards my target. Now let's imagine that this is our final aim. This is our final aim. This is our final aim. Let's imagine that, and let's try to build what we will do. Now we have the current next here. Now simply move all the pointers one step ahead. So my previous was here. My previous will first move on my current. Next, my current will move to my current next. Current next. So now my current is here. Now first thing is, so as to not lose any connection, I will say, bro, current next, I will simply mark. My current next is nothing but current next is my current next. Now I will say current next will be previous. Okay, this connection is gone. Now again, I'm good. I'll simply move all of them. Okay, now my previous will come at the current location, and the current will go at the current next location. And then again, I want to again mark. So again, move the current next again to next step. Current next is now here. Again, we have got all the locations. Now currents next will become a previous. So current I will mark as previous. So this connection will go away. Now again, move everyone one step ahead. So previous will again come here. Current will again go to the current next, and then current next I will try to again go to the currents next. So current next is here. Now again, mark them. So I'll simply again mark them, which means currents next I'll make a previous. Okay. Now again, try to move. So current, so this previous will come here. Now current will go here, and then, oh, current has become null. Oh, so I can simply say, while my current is there, while my current is not equals to my null pointer, I can simply keep on applying this operation. Operation was, as we saw, firstly generate the current next. This will be currents next, and then when this current next has been, you have got this current next, then say currents next will be previous. When you have built the connection, now you can simply say that, okay, previous is equals to my current, and my current is equals to my current next. And by this, you can simply keep on looping and building your connection backwards. Now, when this entire portion is done, you have to remember, you have to return the head. Now you can see head is the previous. So simply you can return the head and say return previous. And that's the only thing which you have to do. Only thing. So you will see the code will look exactly same. That firstly, you have your previous pointer initialized to null and current pointer pointing to head. Then you will just simply loop on while your current is not equal to null, and then firstly get the current next, then build the connection from the currents next to previous, and then move everyone, shift one side everyone, which means previous and current. And ultimately you saw that your previous will be pointing to head. Now this is the most obvious solution, which is time of O of n and space of O of n, and also the most intuitive. Now, but the interviewer usually ends up saying, can you please give me the recursive solution, which is the most tricky one to think of. Now again, for sure it's a recursion, which means it will be going in depth. Recursion is go and then come back. So for sure, if I'm going inside a linked list, for sure it's a list. I'll go inside the linked list in depth and then we'll come back. For sure, a space of O of n can be used. So here we saw that, okay, we are using no extra space. We are just iterating on the linked list. So time is O of n, space is O of 1. But in a recursion, the space will be O of n, which means for sure on the front of our eye, we know the recursive solution will not be optimal than this iterative solution. But still, interviewer wants us to know our recursive knowledge. So, and again, that's the reason he is asking for us. Now, we'll again, very basic. We will always remember what we have to do. So we remembered, okay, this is the input which we are given in the pink, and the purple is what we have to return as an output. In the very basic thing, in a recursion, I will have to go, okay, I know one thing, I will start from the head itself, which means I'm starting from the one itself, and then I go in the very deep of this entire recursion. And as I say, I go in the deep, I'll say, okay, I'll go on the 2, 3, 4, and 5, which means, okay, recursion will go in the entire deep, and then recursion tries to come back. Right? So when I'm going in the very deep itself, as soon as I have reached the super deep, I should assign that super deep to my new head, because I know that super deep thing is the last thing, and that last thing should be my new head. So now one thing I got to know is that, okay, my new head is what I have to return, first thing, and that new head is in the super end of this recursion. This new head is in the super end of this recursion. And lastly, in a recursion, okay, we have not seen the actual recursive case, but by this fact itself, you would have seen that, okay, what is the recursive case itself? See, you are going super deep. super deep. So for sure, let's say the recursive function name is solve. So how to go on to something deep? As in a simple tree. Usually you have seen recursion in a tree or a graph. In a tree, you just go on to child. For a node 1, what is his child? His child is next. So I can say, if I have to go on to, so if I have a node, I'll go on to nodes next. That will be a child of the node. And I'll keep on going on that child so as to go into the deep itself. So I know that this is my recursive case. I can easily see my recursive case coming in. And also, as I go into super deep itself, that will be my new head, which is the last head. Now, for sure, in a recursion, we also have a base case. What can be a base case for a simple recursion? Okay, if I have null as a node, for sure that's a base case, which means my head is itself a null. Or if my head next is a null, which means I have just one node. Okay, one node itself. That's a base case for us. Aryan, why not only head as a base case? Because bro, if head is null and if you try to point and if you try to ask head next, it will give me a null pointer exception. If something is null, I cannot ask for its next. So that's the reason it's good on a safe side, keep head and head next. Okay, if head is null or head next is null, that's my base case. So I can simply say that if my head is null, which means if my element itself is null, I have only no element null. Or if my head next is null, which means I have one element and then that's it. Then I can simply return the head. In this case, it will return the null itself. In this case, it will return the head itself. But it's one element. In this case, it is no element in this case. Now, okay, our base case is sorted. Our things are sorted. So if I just, by so much knowledge what I have so far, if I try to build my recursive example or my recursive code, how it will look like. Again, that's how you should go about in an interview. Aryan, I will try from the very scratch. Okay, keep on try running. You'll get confused. Firstly, get the basic knowledge and then try to build or correct that knowledge. Cool. Now, so a simple recursive case, let's imagine our recursive function name is solve. I will be given the head of the linked list, right? So I remembered my base case will look like, okay, if my head is null or if my head next is null, then simply return the head. That's it. We also recognize the actual recursive case will look like, okay, solve function, keep on going on to my child, keep on going on to my child. Which means head next, head next, head next. And as I'll keep on going, as I'll reach on to super end, the whatsoever I have will be my head, new head. Because see, this will keep on going, head next. Okay, although I showed you in the dry run also, but yeah, this is the head next, head next, head next, head next, head next. So it is simply keep on going on the next itself. It will simply keep on calling my solve function again and again. And ultimately it will stop on to, okay, when the head is null or head next is null, which means I have reached on to my super end node. And ultimately we know that what we have to return is, we have to return the new head itself. That's a final name. We have to return the new head. So ultimately you know that you have reached a super end. So return this new head. Now, we have seen this a basic structure for sure. We have just simply iterated on the linked list. That's it. And by this simple logic, what we will end up doing is we have this list 1, 2, 3, 4. We will simply be keep on iterating, and ultimately we will be returning this head. That's it. So I will be returning this head, which actually in turn in the example by the actual question itself, it will give me a 4 because the program of LeetCode starts reading from this point. So if I'm returning this new head itself, my program will say, okay, you have only one element, which is 4. That's what the program will do. But again, you know, the other operation which I have to perform in this recursion is reversing the links. So yeah, how we will go about that? Simple. We will do exact same stuff. We know that, again, we just simply see our recursive function. We know that our new head was simply solve of, okay, heads next, go on to my next. Okay, so I will simply say that in the very beginning I have no head, which means I have the head and that head is pointing to the head itself. Now I will simply say, okay, my new head is nothing but mine. Again, let's imagine the head as h and new head as nh. So my new head will say, okay, I am here. Okay, great. Then my head will move next. Again, this head moved next, it start pointing to new head, right? Then I'll move and say, okay, now my head again, because as soon as the new head, if I go back and tell you with this example itself, So now as my head was, let's say 1. Okay, let's take an example. My head was 1. So once next it will call, say 2. So once next is actually a 2. So new head will technically be pointing to 2. Now, when this new head, which means heads next, it will go and call for 2. Now 2 will come in as a head. Heads next, it will again go and call for 2's next. Now 2's next will be a 3. So again, remember, make this fact. Head is right now this, and 2's next will be the new head. Okay, great. Now again, 2's, which means heads next, which is right now 3. 2's next is 3. So again, 3 will be gone and called here. Okay, let's erase this all stuff which is dirty. So that we can have it much more clean. Yeah, heads next. Now 3's next. 3's next it will call. Okay, 3's next. Now 3 has become head. 3 has become head, and 3's next will become a 4. It is a new head for us. 3's next has become a 4. Okay. Now again, we have reached 4. So again, 4 will come here. 4's next. So right now, 4 is the head, and 4's next will become a new head. So it will go and ask, okay, 4's next, which is 5. So it is a head. Head is 5 right now. Again, this head is 5 right now. I am calling for from this. I called for 4's next. 4's next. 4's next was a 5. 5 went and called here. So 5 is right now at this head itself. It has not yet come here. So when the 5 is here, 5 is null? No. 5 next is null? Yeah, bro. 5 next is null. Okay. Simply return the head from here itself. So I'll simply go and return back. You saw I did not came inside, and because I have reached my base condition. So as soon as my new head was here, my head was here. That's the reason I told you 4's next, which means 4 is at the head. 4's next was a 5. So it will end up pointing, and it will, when it will return, it will say, bro, I am pointing at 5. So my new head is actually pointing at 5 itself. Now you will say, Aryan, technically, I have got the proper thing. I know this is my new head. I know also that this is my head. So technically what I feel like is, I will say new heads next will be my head. I will say new heads next will be my head. And that should work. Okay, it's equal to your head. And that should work. Technically, you are saying that, and that should work. Okay, yeah. For this step, it will work. But, you know the fashion of recursion. Recursion will actually have to go back. Now, okay, this entire recursion, we have gone the entire deep. Now we have to come back from there, which means our head will actually backtrack. Which means our head will come back, because you remember head was here, then it went here, it went here, it went here and here, and like it keep on going. But you remember one thing, Aryan, but also you showed me, right, that the head was here, the new head was also here, the head was here, the new head was also here, the head was here, and the new head was also here. You also showed me that part. That's the thing. When you were saying the head was here, new head had never returned anything. Technically, by visible eyes, we can see that. And that's the reason where the confusion starts building up. Technically, by the visible eyes, we can see, okay, if my head is here, so the new head will be pointing to the next, which is heads next. It is a simple recursion. New head got its value only when you reach the super end, and someone returned its value and said, bro, I gave you a 5. That's it. When I gave new head a value. So you will see the head kept on moving. Technically my head kept on moving. Head kept on moving. But new head got its value only when it reached the end. Now I have new head, but when we will go back, for sure only head will go back, because we have a new head that's having 5. So technically, whatsoever you have to do, I have spoken technically a lot now. So what you have to do is that this thing might not end up working. Why, Aryan? Because if head will move somewhere here, then you will end up pointing your new head to head. Then when head will move, then you will point your new head to head. Then when head will move, you will point your new head to head, which means ultimately, if you will use this approach, new heads next to head, then you will end up having an answer of 5 and 1. That's a linked list which you will obtain, which means all the middle elements are gone. So what I can do is instead, okay, I know technically, okay, again technically, okay, never. So I know that, okay, new heads next should be head. That's what I wanted. What is new head? New head is heads next. So I can say heads next will be my new head. It's again, I know I can only use my head as a variable, and its next should actually point to head itself. So this is how I can achieve exact same stuff without using new head. Without using new head, I can achieve that part. Great, bro, great. So what will happen with this is that, okay, heads next will be 5. 5's next will become a 4. Okay, but Aryan, so you are saying that, okay, head will come here, right? And again, okay, heads next is 4. 4's next you will make as 3. Okay, that also seems correct. Okay, Aryan, then head will come here while coming back. Oh, one thing. So one thing also, okay, we know this is the code we have to write, but it is while coming back. In a recursion, when anything is while coming back, we write it after the recursive call. Before is while going into recursion. After is while coming back from recursion. So I know one thing that I have to write: heads next, its next should point to head. Right, this is I have to write, but still let's complete the try run. So okay, head is now here. So again, 2's next is 3. 3's next will become a 2. Okay, 3's next will become a 2. Okay, great. Then head will be here. Again, head next, heads next will be a 2. 2's next will be a 1. So 1 should point to head. Everything seems so cool, so fine. And Aryan, I have reached the end. Wallah, I have got the answer, because from here I started and I have reached here itself. I got the answer. You will say that, right? You were absolutely correct. Just one thing you missed. Once next should also be a null. That you missed. Once next should be a null, because right now once next is pointing to 2. It is an infinite loop. So once next, although in this cases it was never mattered that, okay, my 3's next, because I know in the next iteration, in the next loop itself, I will point my 3's next to 2. I know that fact. But in the last, when I reach the super end, my once next, it should also become null. So ideally what you can do is, as soon as you have reached the end, you should make a if condition. Okay, if condition, if this, mark this head as next as null, which means head next should be marked as null. But Aryan, this is only for the last case, right? Null PTR. But Aryan, this is only for the last case, right? So why are you writing this in the recursion? Because it will not matter as such. Why it will not matter? Because I'm saying, okay, if my head is here, so when I build, okay, 4's next is 5. 5 next I pointed to 4. This I did. I'm also saying, okay, I'm also saying that 4's next I will point to null. Then when my head will be here, then when my head is here, I know the 3's next, because 3 has the connection. 4's next I pointed to null, but 3 has the connection. So I can just go and ask, 3's next is 4. 4's next is 3. So I'll mark my 4's next to 3. So this null will actually again overridden and said, okay, 4's next is 3. And then, okay, 3 next again mark as null. That's how. This will not be affecting us anyway, because anyway, in the next, when it is for the next iteration, for the next backtracking, for the next, when it is coming back from the recursion, it will actually override this null and will point it correctly. But it will help us in the super end. Our null, our head will be pointing to my null. And that's the case. That's the case. You will see that this recursion took much more time than the actual iterative, because it is very highly likely people get lost in this recursion, because it's not easy and people get lost in this. Cool. And again, it is much harder than the actual tree recursion, because it's a linked list. In linked list, we work by addresses, next, previous, all that stuff. That also makes a bit confusing. Now, the code is pretty simple. We know that we can actually don't need a solve function or solve recursive case. We can simply use the existing case. We can simply make the same function as a recursive call. Firstly, a base case, if the head is null or the head next is null, simply return the head. Now, I'll make a new head, and this new head will only be populated when I will go in the super end, right? So I'll simply keep on calling my recursive call with the next until I reach super end. So as soon as I reach the super end, I will have my new head. Now, while coming back, I have to build the reverse connections. So I'll say head next, which is technically the next element. Its previous, or basically its next, should point to my head, as I showed you. As I showed you, I'll just repeat once again. So this is the head. I'm saying this is the, okay, this is the head. So I'm saying heads next. So this is head next. I'm saying its next should point to head. So I'm saying its next, which is this arrow, it should point to head. That is this operation. And ultimately, we also know that in the end, we will be requiring heads next, because if the head is here, so heads next should be a null. So we can also keep on doing parallelly while doing the recursion itself, that heads next is null, and ultimately return the head. With this, you will see the time is still O of n, because it's O of n inside, O of n outside, but space is also O of n, but space is also O of n because of the recursive stack used by the recursion. Cool. And that's how you will solve this question. Again, this is a very important question, especially people will for sure go and ask you the recursive case for it, because it's not easy. Bye bye, take care.